All right, so let's explain a couple of these. Number 8, you want to get it in function form. You want to get y by itself. So what would you do to get rid of that negative 2 that's being multiplied by y? Divided by negative 2. Divide everything by negative 2, divided by negative 2. So your new function form equation will be y equals, what is 4 divided by negative 2? Negative 2. Bring down the x. And how about negative 2 divided by negative 2? Plus 1, positive 1. That is your function form equation. Once you have the function form equation, then you could go for an xy table and plug in 3 easy numbers. And in this case, 0, 1, and 2 will work because you don't have a fraction in front of your x. So when you do plug in 0 right here, think about that, guys. Negative 2 times 0, what's that? 0. And what's 0 plus 1? 1. So that is an answer. That's a solution. That's a coordinate. Let's plug in 1 now. Take 1 for your input. Put it in. Negative 2 times 1? Negative 2. And what's negative 2 plus 1? Negative 1. So when you plug in a 1, you get out a negative 1. And that is a coordinate as well. Let's take the number 2 and input it right there. What's negative 2 times 2? What's negative 2 times 2? Come on, guys. And what's negative 4 plus 1? Negative 3. Thank you very much. So we have these 3 coordinates. Let's graph them. 0, 1 is right here. 1, negative 1 is right here. 2, negative 3 is right here. Those are 3 coordinates. Those are 3 solutions. Those are 3 answers to our variable equation that has 2 variables. So we put arrows on it to represent the rest of the answers because there's an infinite amount of answers. And that's how you do it. Any other ones that you would like to see? 6. Remember, g of x is the same thing as a y. So you could just, if you really wanted to, you could just do this. You could cross that out and put a big y right there. Y equals. Okay. So is it in function form? Is y by itself? Yes, it is. That's right. Okay, so let's do an xy table. Could I plug in 0? Always, because 0 always works. Check it out. 1/4 times 0. What's 1/4 times 0? Anything times 0 is 0. And then 0 plus 2? 2. So that's a nice, easy point. Might as well graph it right now. 0 on the x, 2 on the y. There it is. Put the dot right there. Let me do it in red better. Okay. Now, instead of plugging in a 1, because if I plug in a 1, 1/4 times 1 is 1/4, and then plus 2 to get 2 1/4. You get fractions, it's not cool. So what number would be nice to plug in right here if my denominator is 4? 4. So let's actually plug in that exact denominator value, 4. And let me actually show my work here. 1/4 times 4 plus 2. And I'm plugging the 4 right into parentheses where my x used to be at. And of course, when you take any fraction and multiply it by the denominator, it will cancel out. And you will have left a regular 1, no more fraction. So 1 plus 2, what's 1 plus 2? 3. So when you plug in 4, you get out a 3. Let's graph that. 4 on the x, 3 on the y. And there's our coordinate. We could already draw our line because a line only really needs 2 points anyway to be able to draw it. Yeah. Where do you get that from? So that was a good question. You just asked, where did we get the 4 for the x? Yeah? So whenever you have a fraction in front of your x, when it's in function form, when y is by itself, when you have y equals and you have a fraction in front of x, you don't want a fraction. You don't want to graph coordinates that have fractions in it, right? So the input, instead of 0, 1, and 2, you could use any numbers you want. So let's use that denominator itself. So that's why I'm plugging in a 4 right there. So if you ask, where do you get the 4 from? I'm plugging in the 4, knowing that it's going to cancel with the fraction. It's going to make the fraction disappear. Another nice number to plug in would be 8, or maybe even the same denominator, 4, but negative. Those are all nice numbers to plug in, okay? Or once you have 2 points, you could use the pattern up 1 over 4 and go backwards, down 1 over 4, down 1 over 4 this way, if you wanted to extend your line this way. Anyhow, which other one would you guys like to see? The bottom three are pretty entertaining. 12. So let's take a look at number 12. And what is step one on graphing with the XY table? Getting y by itself. What do I need to do to get this y all by itself on the left side of the equal sign?
Subtract 6 and then divide by -2.
Yep, let's get rid of the 6 first by subtracting it. Now, what do I have left? I have negative 2y equals, could I actually do 3x take away 6? No, I can't. All right, it's like saying I have 3 cookies and I owe somebody $6. You know, they're not the same thing. They're not like terms. So I just need to rewrite it. 3x minus 6 it is, because I can't really subtract it. So now my final step to get y by itself is to get rid of this multiplication of negative 2 in the front. So what do, Luis?
Huh?
That's right, you divide by negative 2. The whole thing. Everything by negative 2. So Luis, check it out. The negatives 2 cancel. You end up with y equals, now 3 divided by negative 2, you can't really do it, so I'm going to leave it like a fraction. But that negative sign that's on the bottom, it's probably better if we put it in the middle or up on top. So negative 3 halves x, and then plus 3. Why plus 3? Because a negative 6 divided by a negative 2 is a positive 3. And notice that I took this negative sign and put it up on top. So now that it's in function form, now that y is by itself, now I could go for my xy table and plug in 3 easy numbers. 0 always works. When I plug in 0 right in there, 0 times anything is 0. So 0 plus 3 is 3, and that's a coordinate. Now, what would be a nice number to plug in? 2 would be nice. Whatever your denominator is, use it. So let's plug in a 2 right there. So let me rewrite my equation. Let me show my work here. I want to put a negative 3 halves times, we said we're plugging in a 2, and then plus 3. So the 2 on top and the 2 on the bottom. In other words, if I multiply a fraction by its denominator, the fraction disappears. And I do have a negative 3 left over plus 3. What's negative 3 plus 3? Is 0. So just with those 2 points, you could already graph your line. Let's go to 0, 3. 0 on the x, 3 on the y. And let's also go to 2, 0. 2 on the x, 0 on the y. And those are our 2 points. You could just connect the dots, put some arrows on it, and you're done. Now let's say you wanted one more coordinate. Let's say you're bored on a Saturday night and you wanted another coordinate and you don't want to just use a pattern. What other number would be nice to plug in? 4. So if you do plug in 4, let me do it in red. Check it out. Again, you're going to have negative 3 halves. Let's plug in times 4 and then plus 3 at the very end. All I did was plugged in the 4 right in there. So I have negative 3 halves times 4 plus 3. Negative 3 halves times 4 plus 3. So the 4 up on top and the 2 on the bottom will cancel out. 4 divided by 2 is 2. So you still need to multiply negative 3 times 2. What's negative 3 times 2? Negative 6, and then plus 3 at the very end. That'll give you a negative 3. So 4, negative 3 is the correct coordinate, the correct answer right there. So 4 on the x, 1, 2, 3, 4, negative 3 on the y. Put a dot there, and you'll feel pretty confident because that dot is on that line that we already had drawn. Make sense? Now, did we actually have to plug in 4, do the math, and get out negative 3? No, you could have used the pattern. Down 3 over 2. Down 1, 2, 3 over 2. You could have gotten to that point anyway with the pattern instead of actually showing your work. But you at least need 2 points to draw any line. So I hope these examples have been good. Are there any other ones that might be confusing you right now? 10? 10. I want to get y by itself. So I'm going to go plus 6 first. Plus 6, which I cannot do, so I'm going to rewrite it. I'm going to have 3y equals, rewrite it, negative 2x plus 6. To get rid of that 3, I need to divide by 3, divide by 3, divide by 3. So my new function form equation is y equals negative 2 over 3x plus 2. And now you could jump to an xy table. and plug in 0. And what else would be good to plug in? 3, right? If you ever have a fraction, use that denominator. Let's just go with those two. Plug in 0. Check it out. Plug in 0. Negative 2/3 times 0 is still 0. And 0 plus 2 is 2. So that's one answer, 0, 2, which is right here. And now let's plug in 3. Let's show my work here. We have a negative 2/3. We're going to actually plug in a 3 right in there, and then plus 2. Once again, all I'm doing is taking my 3, plugging it in right here. It'll say negative 2/3 times 3 plus 2. Negative 2/3 times 3 plus 2. And of course, the 3's cancel out. What do I have left? Negative 2 plus 2. What's negative 2 plus 2? 0. So those are my two coordinates, my two answers. Let's graph 3, 0 now. 3 on the x, 0 on the y. Connect those dots, and you have yourself a line. I'm stopping right there. Hopefully, you guys could finish the rest.